Thank you for joining. So today we're going to talk, if folks came to the session yesterday, we talked a lot about things like natural interactions. What we hope to do today is to show you a little bit about how we build some of these natural interfaces and how we build with natural language programming. So we hope what you really take away from this is just some of the strategies you might use in your own practice to string together some of existing AI capabilities out there with things like plain language. Great. So I just want to start with a somewhat simple poll. I really like, let's see, this is never, okay. I really like doing these hand polls, but the hand poll is more like a, let's use it as a diagram or like a gradient. So over here is how often are you using AI when you program? Are you using it never, sometimes, or most of the time? Can you give me? All right, so we have a gradient here. Wow. Yes, super helpful. And I want to ask this question: at what level of abstraction, low, medium, or mid-level or high, are you using with AI when doing so? So let me just give you an example so this sounds more specific. So low would be you're training AI models or you're building AI models. You're kind of doing that low fundamental level with AI, building the algorithms. Mid is like you're doing API calls with things like OpenAI. Maybe you're doing function calling or you're chaining AI together with things like agents. Or at the like very high level, you're using AI for code completion. You're using either like ChatGPT or Claude or maybe something like Copilot that's writing the code. So can I get, again, a show of hands, kind of like, what are you doing? Yes, I do a lot of that too, actually. Most of my time is over here. Yeah. So what we're going to show today is really a lot of our practice is at this mid-level design patterns. If you asked me to build AI or train AI, I would be the worst person to talk to. I have no idea how to do that, okay? But what we do is really this kind of middle tier. How do we string together existing AI capabilities? How do we use some of like this natural language programming, which I'll describe in a moment, to build our own systems? So when I say natural language programming, all I mean is kind of, in some ways, what you're doing already when you said, I'm using ChatGPT or Replit or Copilot to develop code. These are some of our students' websites. And a lot of these students came in with very little programming knowledge. But were given some tools to figure out how to develop their own websites. And you can see they're pretty sophisticated and unique. If we saw these 3 years ago, you would be blown away that anyone can do this without any programming knowledge. But the tools are getting so much better. Do you want to speak to this one?
Sure. And as part of natural language programming, you could imagine that the challenge is you still need to describe programming logic, but in this case without the syntax and semantics of a formal programming language. So when we teach this, we're starting to build up this vocabulary to show students, well, like what is a conditional? What is control flow? what is an imperative command, what is a sort of declarative calculation. And it's really a partnership between that set of vocabulary and the execution environment that they're going to use that in. And so that's part of the design challenge as well, is it's not just about sort of replacing individual lines of code with something like English, or like where you get something like AppleScript. Like AppleScript, I don't know if you've worked with it much, but I think it's really beautiful to read, but it's really, really difficult to write. I think because it just confuses my like English semantics with the semantics of the AppleScript itself. So we're not trying to create another AppleScript. We're actually trying to create kind of, if you were to learn a kind of logical way of expressing a process or some sort of desired outcome, how would you express that to a machine? And how can we use AI, at least modern large language models, to sort of smooth over that gap? And so, for example, like in one of the demos that we showed yesterday, where we say, like, I have an RFID reader, but then you can rename that RFID reader to something more fluid, like the person sitting down. And then you have a lot of flexibility now, because it's not literally a variable called person sitting down. You can sort of flex and move that expression of, like, you know, the person sitting down, the person seated, things like that, and it will adapt and adjust. And the large language model will still allow you to kind of trigger logic based off of that. And so that allows us an enormous amount of flexibility, but there's still a lot of responsibility on the user to know how to express themselves. And I think a similar analogy as well is to, like, the way that lawyers think and, like, lawyers express and interpret the law. That can be a very logical kind of thinking, but it's all expressed in a kind of formalized natural language instead of a kind of formal programming language.
Great. So I want to show a couple of examples of what this looks like from our students, and then we're going to do a live demo. And so I know you all appreciate this, because there was a lot of I'm using AI for code generation. Live demos with AI code generation means half the time it works. So you can see how the sausage is made. All right. So this is just a student that's used the same environment that we've developed, and all it is a natural language program they've built up that's, when they look over in this direction, please turn the light on, that focuses on this piece of art. So it's kind of cool that you can program things also beyond what's in this particular computer. I'll see if I can click it. Maybe not. That's okay. We'll come back to it. Okay, so you've probably seen a lot of these programming environments starting to emerge. It's not just things like Copilot that are writing code for us. Some of the area we're really interested in is, how do we get designers and people that don't have access to the power of programming to have some of those same capabilities? And so when they see code or syntax, they get really stressed out. It's like, what does this mean? How does this actually function? So we're really interested in this way of democratizing some of the power that you all know from programming. And we've seen an emergence of these kind of programming environments that are geared towards designers. Great. So I'm going to show an example now, and you can all enjoy this live chaos together. All right. So this is our programming environment called Procession. Let's try to do something. All right. So I'm going to say, Can you show my webcam? And hopefully this picks up on this webcam. Oh, hi! All right. Now let's say, can you track my hands? All right, so now we have our hands getting tracked. Well, let's actually just do just my index fingers. Maybe put a white dot for the index fingers. Fingers. I always feel like I have to correct my spelling. Maybe over time I won't. Real big, please. Real big, please. So we'll see how it interprets that. All right, what about William's hands? Did they come up?
Yeah, it should track.
Oh, interesting.
Yeah.
Okay, great. Are you putting your fingers up behind me? Not cool, not cool. I can see it.
Yeah. I know you can.
All right. Cool. So now let's see how we can develop this into like more of a program. Let's try and do something where we're going to put something like a square on one side of the screen, and then we can track whether my hand is over that part. And then when my hand's over that part, let's do something like make a timer that only starts when my hand's over there. So what's nice about this is like a very simple program, but what's nice about it, if any of you saw the demo yesterday, this starts to talk about natural interfaces. So for example, yesterday we talked about if I sweep, a natural interface will track whether I swept somewhere rather than me like clicking a box on a GUI or on a GUI that says I swept. So here we're going to do something similar where we make a box, see if my hand went over there, and then start a timer. So let's start by just breaking this down. Can you make big red box on the left of the screen? And maybe we can show them a little bit of how this is working. Okay, great. So now we have me, we have my fingers, we have this red box. And every time it's building up each one of these prompts, we're also, that's actually executing or like writing out this code. Do you want to say anything related to this part?
Well, the primary rendering engine that we're using is P5.js. We mentioned yesterday, processing is this project out of the MIT Media Lab. I think it was released in 2002-ish by Casey Reese and Ben Fry, and it launched this whole creative coder community, essentially. And there have been several offshoots since then under the umbrella of the Processing Foundation, one like processing.py for Python, and then the original processing is Java-based, and then the P5.js is the same APIs, but in JavaScript, so executable straight in the browser. So what we discovered, what we actually stumbled across when we were starting to use LLMs in our teaching at Columbia was that the GPT models know P5.js. I don't think that's probably surprising to us now because the models that we have are so kind of good and robust at generating code. But at the time, it was kind of a big surprise. I think it was a surprise in that we started discovering that you could just like copy paste the code that it generated into the web editor, and it would just work. And so that got us really excited about, at least for that particular class, being able to start to engage these programming concepts at a higher level. And so the program we teach in is called the Computational Design Practices Program, and it's designed to help kind of bridge this gap between spatial designers like architects and this creative coding community. And so we get a wide range of students that come in, some who are like software engineers by trade and others who have never seen a line of code in their lives. And so how do you help them like get into this world where there are increasing numbers of tools and increasing incentive to use computation and software in spatial design. So right here, like what you're seeing is the output of like what backs procession right now is the OpenAI API. We're looking to extend it, but that is the generated code that you're seeing. And I'll show you here in a little bit, a bit more how that works, and a bit how it, a bit of the lessons we've learned and what you can take away from it. So.
Great. So let's make this more interesting. What did we say? We were going to make a timer. So yes, can you make a big red box? Can you, let's track if my finger is over that. So can you make a big white text box on the right side of the screen, or I'll just say text, that says on the right side of the screen if my finger is on the red rectangle. Otherwise, make it say off. So I feel like this is one of those areas where, when I say make it on, otherwise make it off, that's kind of what, oh, there we go. Off, on, off. Oh, so satisfying. So easy. Great. Now let's turn it into a timer. Now, instead of saying on, can you have this be a timer in seconds counting up? That is only on when my finger is over the rectangle. So you see, like, there's a way that I'm prompting this that you're all probably familiar with. It's like very simple. Just show me the webcam. Just show my hands. Just do this on-off thing. It's one of the things that I found in my LLMs for UX prototyping course is that if you ask for a very complex program, it doesn't ever work. Very rarely. And so you really have to break down those steps, like do the pseudocode yourself to some degree so that we can make it simple. Okay, so let's, oh, yes. Oh, say that again? Oh, yes, absolutely. You could say, show my webcam. You can keep it very simple. I think with some of this prompting, I don't know why I say please. Maybe it's so that when like AI takes over, it's not angry at me. But yeah, like sometimes I feel like some of those extra descriptions can help. But you can just say like webcam, please, and it might actually respond because it's just inferring what you mean. Let's add a sound. Sorry. Let's say make a chime sound every 10 seconds of the timer, like that. What's 10 seconds? 10, 20, 30, you get it. So I mean, I could have simplified that. I could have said like chime sound every 10, 30 seconds, but it might not be able to, like, it's hard to say how much it needs, like if there's a clear breakpoint of how much you need to explain. Oh yeah, do it.
Oh, 10 seconds is a while.
I shouldn't.
Is it going to work? Oh,
Yes! You're not going to go all the way to 20? Okay. No, it's okay. It's okay.
okay.
Yeah.
Yeah. Yeah.
Yeah.
So the question was, how do we ensure that there are no errors in the code that's generated? And the answer is we don't. When there's an error in the code, it says like there's an error in the code, and we go from there. And that's another part of like the, I want to say roadmap, but like we know that we have to do some better error management, and the execution strategy that we have. I'll show you what it kind of looks like. It's not ideal. But yeah.
Yeah, but you see, I mean, this isn't surprising to you all because you're probably writing a lot of your code using AI. But it's so nice that it picks up the semantics that we're talking about. So, I didn't have to specify timer, but we've got a timer here. We have this logic for finger, and there's probably something in sound somewhere here. Oh yeah, sound formats. So one of the things that we're doing that helps a lot of this is just trying to string together a lot of existing libraries that we know we're going to use for this kind of off-the-shelf stuff. So having things like the media pipe libraries, if you're familiar with that do vision, or using P5.js and some of the sound capabilities there. That just really alleviates a lot of the things that our students usually get stuck on, which is like the integration of libraries and like some of the steps leading up to that.
Yeah, that's right.
Great. 2 options. Ooh, let's let the audience decide. 2 options. First, show the diagram of how this is actually architected, and William can talk through that. Or someone from the audience can try and prompt it themselves, and we'll see what happens. All right, let's see how it's architected. Okay. That'll give you a better sense of how to prompt it anyways, because or else you don't even know what you're asking for, right? All right.
Cool. Yeah, and you can keep that window open.
Okay, great. And somewhere I put that presentation we had.
Is it full screen? There you go.
There we go. All right.
Okay, good. So I can swipe. I think I can swipe back and forth, can't I? Where am I? Great. Okay. Apologies for not sort of breaking this down and like walking it through like step by step, but graphically that is. But we'll walk through it step by step verbally. So really the core of this, of course, is the OpenAI API, and there are services out there now that support the same API, so you don't necessarily have to point to OpenAI if you want. You can use their SDK and point to, I think Hugging Face has an API that you can use as well and sort of pick your model. And at its core, it's just this flow here where there's a user prompt starting in the lower left, and that's combined with a bunch of other stuff. And then that's sent to the OpenAI API, and then you get back a chunk of code in P5.js that's then executed. And so a lot of the challenge is to get the P5.js code running. So P5.js is this project, again, mostly for creative coders, and it's used a lot in education settings. And the API is quite simple. It's essentially just an event loop model with a graphics model it's an event loop model with a kind of graphics model that's somewhat similar to OpenGL. It's like stacked transformations. So, and there's a bunch of convenience functions so that you can do things like string manipulation and whatnot without necessarily learning the the actual string API from JavaScript. So so that's what we're running. And we do it in a way where we can manage that event loop and then restart it when new code is generated. And so P5.js gives you the ability to sort of wrap all of that logic up into a single object and then start and stop it and then refresh it at will. The place where things get interesting are how we manage the integration with other libraries and the sort of prompt manipulation that we do to actually build up the message that goes to OpenAI. And so how many of you are familiar with the OpenAI API and like the messages, like how messages are organized and all that? So, okay, so about 40% of you. Well, the way the API works is it's essentially just a list of messages. And messages are have two required properties: a role and a content. And the role is generally one of four: system, assistant, user, and tool. And then the content depends on the role. So typically, a message is just the content of a message is just a string. So you would think like what the user inputs into ChatGPT and then what the response is when you get back. So what we do, though, is we use a few techniques to help us with this environment. So one is, first, we do this in the browser because there's a bunch of APIs already available that are kind of standardized that you can call upon, like obviously the webcam. But there are other things like serial device APIs now that are supported in like Chrome and Opera, I think. So you can access serial devices like Arduinos and like RFID readers and things like that. So we use that, and we have a thing that manages that outside of that event loop. And then we have a series of modules that are essentially integrations with other things. So one being what you're seeing today is MediaPipe.
I've been looking over here.
Is it better to see over here?
Yeah.
Oh,
yeah.
okay. Great. So MediaPipe is a library from Google AI, and it provides a number of sort of out-of-the-box vision libraries and text libraries that you can use. And the nice thing about them is once you get the first MediaPipe library sort of set up, you can really easily integrate all the other libraries. So we have like so Procession right now has like face detection, face landmark detection, object detection, things like that. And so I want to show you one of them because it sort of gives you an idea of what is involved with taking an outside library and sort of injecting it into a context where you want natural language to be the driver of behavior instead of like literal function calls, function signatures, parameters, and so forth. And so the API documentation is here. There should be a link to trying this out. Let's see if we can find it. Aha, code example. And so I don't know if you know who this guy is. We miss him. But so this is face landmark detection. And this is set up in a way where if you click, it shows all of the results of the model. And it's a typical discriminative machine learning model. It's trained on a number of sort of gestural, interesting gestural behaviors like whether your left or right brow is up or down, whether your mouth is open, whether your eyes are squinting, things like that. And so what happens in Procession is we wrap up that functionality in a way that manages the life cycle of that library. And so we provide a start method that starts the vision, and then we provide a little chunk of text for the system prompt. And so again, how messages are expected in OpenAI, for those who don't know, you typically start out with, like, you send a set of messages to the API, and the first one is typically a system message. And that one has, like, essentially keys to the kingdom. It's the one that's prioritized the most. And so we put most of the behavior of procession and the expectation into that system prompt. So that's down here, sort of managed in the chat manager. We also have a little tiny prompt that we place in front of every user message. So we have a system message that's sent, and then it's just a list. So you append to that a user message, and that's typically the first, what you would experience in ChatGPT is the first message in an empty chat. And then the next message that you get is generated by the LLM, which is a role of assistant. And so that includes that text. When we get a response from OpenAI, it's just code. It's just the P5.js code without any explanation and whatnot. And so the rest of the messages alternate like that: user, assistant, user, and so on and so forth. And every submission, you send all the messages to OpenAI and get back the next one, which kind of makes sense, right? Because, and that has a lot of emergent behaviors to it. Like if you ask ChatGPT to explain itself first, you tend to get better answers when you ask it a question, rather than to say, give me the answer, and then ask it to explain itself, because it's including everything that it generated in the next token prediction, which is kind of a curious emergent behavior. So what we do is, whatever modules, it's kind of a weird kind of flow, because whatever modules are available, all of these little system prompts are appended to the core system prompt. So now we have this big system prompt that's at the start of the chat. And then all the other previous messages, if there are any, are injected after that. And then the user says, like, start my webcam. And then we inject a little chunk of prompt right in front of that in order to make sure that we're aligning with the instructions from the system prompt. So we can say something like, create a p5.js sketch that has such and such expectation, and we put that in front of that. We do that because we need to separate a few things. We need to separate what a user is typing, which are really straightforward commands like show my webcam, add a sprite to the canvas, track my hands, from anything that depends on sort of the version of the system. So as we improve, we want to be able to separate what we're improving from what the user has said before. So when the user comes back and there are improvements made to procession and the system prompts, that those can be like more smoothly accounted for. So if the user expects something that we then remove and change, then that starts to break their code, essentially break their code. Okay, so we have all these modules integrated. We have media pipe face detection, so on and so forth. All of their kind of expectations are put into the system prompt, and then we have this start method. That start method is part of that system prompt's responsibility is to say, okay, if the user is asked to track their hands, then here are the instructions by which you should initialize that hand tracking capability, like call .start at the very beginning. And so all of any methods that are needed by one of these libraries are injected into a managed global state variable. So it's a little tricky to manage global state, but we have a variable called globals where all of that is managed. And so at the very start, like we say, okay, all these methods are available, you should call them. And then we tell it, oh, by the way, all the results of your hand landmarks are going to be in this variable, globals dot, hand tracking dot results, something like that. And generally, it works pretty well out of the box with just that kind of description, because it already knows media pipe, like the LLM knows media pipe. But we take it a few steps further and initialize an empty state and ensure that it knows the structure of the objects and things like that, so that it doesn't get too confused. And then that global state gets injected into the P5.js code. And so what that looks like, this is a good example, is something like this. I think maybe we can pump this up just a touch so you can see it a little, well, I was hoping better, but. So for example, like the life cycle of P5.js is preload, setup, and then draw. And then draw is just a regular like render event loop. And then, I guess my hand's like showing up here too. Aha! And so we're balancing the expectations of P5.js as well as MediaPipe. So, and that actually becomes really tricky because MediaPipe's startup lifecycle is different from P5.js's startup lifecycle. And so we have to do a lot of kind of trickery and negotiation to make sure that all that is set up correctly. And so this is another technique when you're doing this kind of, if you're looking into this kind of interactive programming with LLMs, is we don't 100% rely on GPT's knowledge of how to initialize these libraries because it gets it wrong more often than you would think. So, for example, there's a. I'll save that for later. This globals.create capture that encapsulates a bunch of initialization for the webcam that in the first days of doing this, we relied on GPT's ability to do this. And it turned out to be really fragile eventually. And so we just locked up all that logic because it's like kind of boilerplate logic and we need to initialize stuff in a particular way, in a particular order. And for example, this devices panel, so this is the UI for that devices manager box on the diagram. So this lets you pick the webcam that you want, pick the resolution that you want, and add. You can search for serial devices and add them and register them. And so that's how we can get stuff sort of talking to the physical world. And this is a bit of a conundrum because we're like part of the flow. And the kind of development flow is to, in some cases, we just kind of fall back on traditional UI design. So data entry, sort of like, pop-up windows and stuff like that to configure stuff according to the configuration that we have versus relying on the language aspects of it. But more and more, we're going to start shifting some of that logic over to the language side. So you can say things like, set up and, register a serial device, and it would just do it. And so you can, there on line 25, you can see the globals.handtracking.start. So that starts the hand tracking library, downloads the latest model from Google, starts that life cycle. And then because there's a set of, and so that's asynchronous. And so like processing is pretty fast at starting its event loop. And so what we do again, and this is another point, is to provide defaults for whatever global state that you are interested in using. So the hand tracking starts out with just empty arrays and ensures that there are no null or undefined values in that hierarchy. And then when GPT generates the code, it just generates this simple for loop, like on line 47 or 47, 40, and 49. You can see how it unpacks the results, iterates over all the hands, and then iterates over all the points. So we ensure that .landmarks is always an empty array so that it doesn't have to complicate itself with checking for an empty value before it enters that for loop. And so a lot of times what you have to do is shift over a lot of those expectations to that kind of default boilerplate code so that you don't have to ask GPT to check for undefined values, and because that ultimately students don't know that. Ultimately, then you're speaking programming language instead, and you're saying hey, if landmarks is undefined, break out of the event loop. You don't want to do that for this particular audience. You actually want to take care of stuff for them and kind of make it easy with some smart defaults.
Great. So I want to be mindful of time in case anyone has to jump. But if folks want to stick around, we can show a few more examples and do some live programming. But I hope one of the main things that you take away is that you can both that you can architect these systems at the middle level. And actually, that's hopefully one of like the most powerful leveraged things in many ways that engineers have the capability to do in this moment. Building up some of these systems that uses off-the-shelf AI is one of those things that I think can really extend the capabilities of programming. And I just really believe that helping other people have access to developing their own programs is going to be incredibly powerful. So I hope that you join in building systems like this. If you're interested, please reach out. And thank you.
Yeah, thanks very much.
Yeah.